Chapter 2 focuses on solving equations and solving inequalities. So the first half of the chapter will be equations, and then we'll move into solving inequalities. It also has some different word problems in it. We're just going to do a quick review on solving one-step equations before we move into lesson 1. So solving one-step equations, main thing is that you're always trying to isolate the variable. So you're trying to get the variable alone. Doesn't matter which side it ends up on, it just matters. The only thing that matters is that it's by itself. Example 1 says to solve x subtracting 3 equals a negative 8. So what I want you doing with these is looking for, first of all, your variable. So right here is my variable. It's on the left side of the equation this time. I need to move everything that's on the left with it away. And the way that we do that is by using the inverse operation. Inverse operation right here, negative 3 is actually adding to x, or you can say 3 is subtracting from x. So the inverse operation of that, since it's addition or subtraction, would be using the opposite sign to get 0. So I add 3 to this side. If I'm going to add 3 to one side, I draw this line and I think about I have to add it once to this side. It's more important when we get to the multi-step equations that you're looking to make sure once here, once here. So you draw that line to separate your two sides of your equation. Negative 3 plus 3 cancels. I have just x left over, and a negative 8 plus 3, opposite signs, negative 5. And now you check these, and you check them just by evaluating with this answer that you had, with the solution. Negative 5 subtracting 3 equals a negative 8. Negative 5 subtracting 3 is a negative 8. So that is true. And that's how you'll check those. So we isolate the variable by using inverse operations. And we'll just do a quick review of that. Your inverse operations, if you're adding something, then you would use subtraction, or adding a negative if you want to think about it that way. If it's a negative, same thing. You would add the opposite sign, so you add a positive. If it's multiplication, you're going to use division. The other way to look at multiplication is multiplying by the reciprocal. And we'll show an example of that. And then division, you would use multiplication. So let's try just a couple more examples of these very quickly so we can move on to the lesson with 2 steps. Example 2, solve 3/4 x equals 9. So this right here means multiplication. I'm multiplying 3/4 times x. So you could actually divide both sides by 3/4, but that tends to confuse people since there's a fraction there. So this is where we can say, or I can multiply it by the reciprocal. If you were to multiply this by 4/3, now you need to remember to multiply 9 by 4/3 also though. So that's the two sides of the equation. There's your variable. Now if you notice, cross-canceling, because we're multiplying, 4 and 4 becomes a 1, 3 and 3 becomes a 1. So you end up with 1 times x on the left side, and 1 times x is just the x. So now you have x equals, remember this is like a 9 over 1, if you need to think of it that way. So I can cross cancel, or cross simplify here. 3 goes into 3 once, 3 goes into 9 3 times, and now I can multiply across. 3 times 4 is 12, and 12 over 1 is 12. So x equals 12. And now you can check it. And again, you check just by plugging it in and evaluating. So I have 3 over 4 times 12 over 1 equals 9. 4 goes into 4 once, and 4 goes into 12 3 times. 3 times 3 is 9, so 9 equals 9, and it's true. So that's an example of multiplying by the reciprocal. Alright, here's another example. Solve negative 96 equals 4c. So you're always looking for your variable first. Notice the variable is on the right this time. Don't worry about that, doesn't matter. You're still trying to isolate the variable. So you look, and 4 is a coefficient in front of c, which means it's multiplying. So opposite or inverse operation is going to be to divide by 4. Again, or you could multiply by 1/4. But it's easier for me just to say I'm going to divide by 4, divide by 4. 4 has become a 1, not a 0. If it was a 0, you would have nothing there. C comes down, equals, I have a negative divided by a positive, so it's a negative. I do the division and I get negative 24. And then I'm just going to go through this quickly, but in order to check it, negative 24 times 4 is a negative 96. So I did that correctly. Example 4, last example. Solve x over 4. Oh no, there's 2 more examples, sorry. X over 4 equals 11. So again, I have division. Here's my variable. I need to isolate the variable, so inverse operation. This is being divided by 4, so I'm going to go ahead and multiply both sides by 4. Or multiply both sides by the reciprocal of this without the x, which would be 4 over 1. 4 over 1 is 4. So I'm going to multiply this by 4, and I'm going to multiply this by 4. There's my 2 sides of my equation. The 4's become a 1, and I just have an x, equals 11 times 4 is 44. And again, in order to check it, plug in 44 for x. 44 divided by 4 is 11. Alright, one more example, and we'll move into the lesson. This is example 5. Solve. This one it tends to cause trouble a lot of the time, so be really careful with this. It's an easy thing to forget. So this looks like the x is alone and it's already solved, but it's not because you have that negative there. This is like a negative 1. I need it to just be x. So think of this as negative 1 times x. So the opposite, inverse operation, is going to be to divide by negative 1. The negatives become a positive, and I have just x left over, and then I have equals, and a negative divided, or positive divided by a negative is negative 10. And notice if you were to check this, if you use the rules we've learned about evaluating, I'm plugging in negative 10. I already have a negative there. So negative, then I plug in negative 10 equals 10. Negative times the negative is positive 10. And that's how that works. So make a little note over here. if you have a negative x, or a negative variable in general, you must move the negative to fully isolate the variable. And now we'll start lesson 1 of chapter 2. Alright, for lesson 2-1, we're solving two-step equations. And I'm actually going to go over different examples than what's in the book. If you want to go over the ones in the book later, you can. But I could spend all day going over examples of solving these equations. And in reality, you just need to see the basic rules, and then you need to just practice it and get really good at it. Because there's so many different types that come along. As long as you're following those basic rules that we go over, and you get really good at seeing that, then you'll be able to solve any of them. So again, the main rule behind it all is to isolate the variable. That's your, every time it says solve this equation, you know that your goal in the end is to have an isolated variable, a variable that's alone. And you always want to be moving toward that. If you're not doing that, you know you're making a mistake. So I'm going to write down example 1. Solve 10 equals m over 4 plus 2. If you have a highlighter, first thing I would do is go ahead and draw my line in and highlight my variable. So my goal is to get this m alone. I need to move 4, I need to move 2. And there's actually an order that you want to follow when you move these, so we're going to go over that right now. Always move the terms without the variable to the other side first. Okay, so you have to understand terms. Here's a term, here's a term. This is the term without the variable, so this is the term that I want to move first. And it's typically going to be an addition or subtraction. Term. It's typically addition or subtraction that's going to move away from that variable first. And in this case it's addition, so I need to use the inverse operation, which we just reviewed. Inverse operation would mean that I'm actually going to subtract 2, or a lot of you might know this as adding a negative 2. Completely up to you if you want to write it this way. Part of the reason some people tend to like writing it this way is because then you don't accidentally lose your sign over here. Sometimes students move a negative over and just completely forget about it. So you could have subtracting 2, or adding a negative 2. It means the exact same thing. So now I'm going to simplify each side. Positive 10 plus a negative 2 is a positive 8 equals, this becomes a 0. So I just have m over 4 left. Okay, I'm still trying to isolate this m. So now I need to move the 4, and I'm going to look at what is 4, what operation does 4 have to m? It's dividing, so I'm going to do the opposite, which is multiply. If I multiply this side by 4, I need to multiply that side by 4. These 4's become a 1. Now I have 1 times m, which is m. Over here I have 4 times 8, which is 32. Now, because of lack of space on my notes right here, I'm going to go ahead and just mentally check this with you. But on your homework, I want to see a check on the right because you won't have all this. So take 32, plug it in. 32 divided by 4 is 8. 8 plus 2 is 10. So it did balance. All right, let's try another one. Oh, I guess we should write a little more on the left. Sorry. Let's write more on the left first. Okay, after you move that first term, I just went straight into the second one, but we didn't write about it over here. After you do that, then isolate the variable from the term it's included in. And this is going to be usually your multiplication or your division. And this is the one where you also might multiply by the reciprocal sometimes. All right, so you go ahead and try this one based on what you've already learned. Hit pause after I write it down, and then go ahead and hit play and check it with me. Negative x plus 6 equals a negative 11. Alright, so hopefully you went through, highlighted your variable, drew your line. Notice this negative is not highlighted with that variable, so I need to take care of that at some point. And now I'm going to go ahead and start isolating. I'm going to isolate the 6 away first because it's adding. Opposite, the inverse operation is subtracting 6 or adding a negative 6. It's up to you how you want to write that. These cancel and become a 0. I have a negative x equals negative and negative. I add them, keep them negative. That's part of the reason it's nice to put plus a negative sometimes, because then I would have noticed a negative 11 plus a negative 6, negative 17. Now if I'm highlighting my variable, I notice that I still have a negative to deal with, so I need to go to the next step. Negative 1 is multiplying to x, so I'm going to go ahead and divide by negative 1. And I end up with x equals positive 17. Negative divided by negative is positive. I have x alone. Now I can check it. Negative, put in 17, evaluate, plus 6. Opposite signs, find the difference. Negative was the larger. So that is right. Okay, example 3. C subtracting 4 over negative 6 equals 9. Okay, this one's a little bit different, so you're going to have to kind of stop and think about the rules. Remember up at the top I said typically you're going to add or subtract to isolate your variable first, but this is kind of one of those that isn't typical. What happened here is I have this negative 6 at the bottom of the denominator of this fraction, and if I was to split this up, I would have a fraction to deal with that I'd have to move over. So you could have c over negative 6 plus negative 4 over negative 6. And then you would have a fraction to go ahead and move over to the other side and do all of that. Or you can say, well, wait a minute, I'm going to go ahead and I'm just going to get this negative 6 to move away from this c minus 4 first. And the reason you can do that is because each term is being divided by negative 6. I can only do that when I would have to split these up into 2 to be divided by negative 6. Notice the difference. When I look up here, only the m was being divided by 4, the 2 wasn't. Here, they're both being divided by the negative 6. So Opposite of division is multiplication. I can actually multiply by a -6, and then my negative and -6's cancel and become a 1, not a 0. If it was 0, this whole side would wipe out. They become a 1. Now I have c subtracting 4 left over on the left, and then I multiply 9 times the -6, watch your signs, and I get -54. Now this looks a lot like some of your other equations that you've been solving. So there's my c. I want to move 4 away. Inverse operation is to add 4. And this becomes a 0, and I have just a c left over. This becomes a -50. And then I'm going to go check it. -50 subtracting 4 is a -54. -54 divided by -6 is a +9. So I did that correct. Okay, we're going to write some notes about this type on the left just so that you make sure you understand it when we're working on them. And then also remember this negative rule if you need to write that again from the little beginning lesson there. But if the top of a fraction, if the numerator, if you know numerator, denominator, write numerator. If you're not comfortable with that yet, just write top of fraction. So I'd rather have you be able to understand this later. Has variable. You're going to multiply both, and the key is both sides of the equation by the denominator, or bottom of the fraction. Once you do that, then you'll have this equation that you know how to follow the steps to solve further. Then isolate the variable using inverse operations.